Welcome to 5 Questions. I'm Jeff Blyle. Today, it's 5 questions on artificial intelligence with Alex Castrounis. Alex founded InnoArchitect, a company focused on technical education, speaking, and writing. At his day job, he's the vice president of product and advanced analytics at RocketWagon, an enterprise IoT and digital services company. And prior to working in tech, Alex spent 10 years as a race strategist, data scientist, and vehicle dynamicist for IndyCar racing teams. Hi, Alex. Thanks for joining us here on 5 Questions.
Hey, thanks for having me.
So first, how do you define artificial intelligence?
So normally I start with just intelligence as it is, and it's sort of the learning, understanding, and application of knowledge learned to achieve one or more goals. So, again, intelligence is all about just kind of learning something and then using that knowledge learned to achieve something or carry out a task. And, it could get a bit deep and sometimes is related to kind of almost philosophical concepts like think, mind, consciousness, sentient, and all that. But again, it's just learning from something and then applying knowledge learned. So, naturally, the extension there is that artificial intelligence is intelligence exhibited by machines. And, that field is a pretty broad field. So it has subfields like machine learning and deep learning, things like that. And it's very different than what we had before AI or machine learning in that, the key concept here is that you don't have to write a lot of very specific code or domain specific code to carry out certain tasks that are very, very common for artificial intelligence applications, like making predictions, for example. So the idea is you essentially hand some data to an algorithm, and then this algorithm kind of creates a model, learns how to carry out a task, like making a prediction, without having specific knowledge of what domain the data comes from and that sort of thing. So it's really efficient and it's really powerful.
Now, your personal history includes work as a data scientist and race strategist for IndyCar teams. So how can artificial intelligence be applied in a setting like that, like prepping for the Indianapolis 500 or an IndyCar race?
Yeah, absolutely. So, racing is really interesting. It's super technical. There's a lot of instrumentation on these race cars. And so, I kind of relate it to the Internet of Things, for example, which is becoming, such a hot topic these days. The only difference is, the cars and the sensors on the cars aren't necessarily networked to the internet, but otherwise, I was doing a lot of the things that are now considered Internet of Things for a long time, way before people were talking about Internet of Things. So what I mean by that is, you have these super sort of high-tech, expensive race cars, and on there you have laser sensors, you have temperature sensors, pressure sensors, distance or displacement sensors, whether they're, angular rotations or they're linear distances. You have, load sensors to measure actual forces and load in things like suspension pieces, and so on and so forth. So you're constantly measuring, everything about the aerodynamics of the car, meaning, the attitude, the platform attitude of the car, like how flat is it relative to the ground, or is it pitched in one way or another? What kind of aerodynamic forces are being generated, at the front and the rear of the car. Also suspension displacements at the four corners and how weight is being transferred around the car. And that's really, due to accelerations, which is really the sort of fundamental basis of vehicle dynamics, which was something I was very big into in racing. So you wind up having, just a ton of data being generated every single time the car goes out on the track. And most of the time, what makes racing a little bit unique is that not only are you generating an absolute mountain worth of data, in very short periods of time, but you have also very short periods of time to analyze the data and develop a deep understanding of how the data can essentially make the car go faster. So, for example, if you go to a race weekend, normally you'll have, a couple of practice sessions and then a qualification session and then the practice before the race and then the race. And you have to basically understand everything about the way the car is behaving for the given driver in the shortest amount of time possible, because, you could get behind very quickly. And in fact, a lot of people, there's a phrase or a term or whatever in racing that people say, if you're not fast when you roll off the truck, you're pretty much behind the whole weekend. So so there's lots of opportunities in terms of, ways to look at that data and try and figure out the optimal race car setup. The engineers on the team can adjust so many different things about the cars, whether it's front and rear wing angles or different aerodynamic parts to change the aerodynamic behavior of the car, tire pressures, static alignment things like camber, caster, toe, or you can change, things with the suspension like spring rates or damper settings like high speed, low speed, bump and rebound. And really the list just kind of goes on and on. And every time you make these little changes or sometimes big changes, you can directly influence the maximum sort of speed potential of the car, which ultimately the goal is to reduce lap times, right? And that's what makes the car as fast as possible. But then another thing, which was a big thing for me throughout my racing career, was race strategy. So I was a race strategist for many, many years, including in the Indianapolis 500. And there's just so many variables going on in during the race that you can't really predict necessarily. So it's almost more of a probability type game in terms of, when are other people going to pit? If they pit, what kind of tires are they going to take on? Because there's usually more than one tire type you can use in a race. What kind of, adjustments should you make in the pits to the car? You can make some minor adjustments to wing angles, things like that. How much fuel should you take? When should you pit optimally? And so on and so forth. So there's plenty of options for using advanced analytics in professional motorsports.
Well, can you talk about another use case for AI in business, a setting in which you've seen AI be applied effectively?
Yeah, absolutely. I mean, we see AI in businesses all around us at this point. One of the things you hear about often are things like actionable insights and data-driven decision making and so forth. So, a lot of businesses are interested in, machine learning or artificial intelligence for things like that. But also, AI can be used to help businesses achieve certain goals and KPIs, things like that, but also are useful to people using businesses' products and services, for example. But yeah, there's lots of use cases. I mean, you see things like predictions for stocks, trading, and investments, or medical diagnostics, predicting a certain disease or predicting a machine part failure. You see a lot of classification type applications, meaning, classic one is spam versus ham for, emails. Like, is an email coming into your email client, like Gmail or whatever, a spam message or not? But also classifications in medical diagnostics as well. And then recommendation engines, Amazon and Netflix have made those very, very popular. A lot of recognition type applications with speech and audio and text and handwriting and images like object identification or identification like facial and fingerprint identification, computer vision, which includes recognition, but also things like motion analysis, and then clustering and anomaly detection for credit card fraud or cyber and network security. Natural language is really big right now. So things dealing with processing speech or text into different entities or concepts or parts of speech, but also, auto-generating text or even trying to comprehend text, which is really more of that natural language understanding side of things. And then finally, you see a lot of hybrid applications out there, meaning that, they're employing many different machine learning or artificial intelligence techniques like autonomous vehicles, personal assistants like Amazon Echo, Alexa, Google Home, Siri, robotics, VR, all that sort of stuff. So,
And are anything in particular that maybe stands out as an AI application that's out there now that wasn't possible, say, 2 years ago?
yeah, I mean, well, so first of all, a lot of the personal assistant stuff right now is becoming much better than it was. It's still got a long way to go, but that's definitely I don't know if it's only new in the last 2 years, but that's come a long way. A lot of the recognition stuff is really coming a long way with deep learning and using GPUs to kind of make learning more efficient and that sort of thing. I think a lot of the stuff that's being done lately that's sort of advances in the recent couple of years are things involving deep learning and that sort of thing and requiring massive processing power and all that.
What's your advice on how an organization should plan for an AI effort? What resources and what infrastructure does a company need before they can really get started?
Yeah, I mean, so one of the things there is that, I think companies should definitely consider AI in their business strategy. All companies generate and store a lot of data. That's both operational data, right? Internally, like sales data, marketing data, whatever, CRM, CMS, ERP, whatever kind of platforms they use internally. But they also, especially like SaaS companies or software companies generate a lot of other data, that's relevant to their customers, things like that. And sometimes they have like POS data, for example, if they're a retailer, kind of an e-com type situation. And data can be used in many ways. So I think one of the things is, definitely consider it. One of the other things is, the key with using AI in your business strategy is really to start with the goals and the why of it all. And that should really drive everything else. So kind of understand why you would want to use AI. And what those goals are that drive it. So are you trying to increase profits? Is it increase conversions? Do you want to make recommendations to your customers with the hopes of increasing sales or somehow simplifying their experience? Which also, a lot of applications are geared towards improving user experience and enjoyment, things like that. Or maybe making something more efficient with getting a certain job done. But one of the other things is kind of understanding whether AI is actually needed or not. I mentor a lot of entrepreneurs, and it's interesting. There's this term premature optimization, and so many people often, it's funny when they're thinking of doing a software application, for example, for some reason it's sort of natural almost to kind of already start worrying about needing scale like Netflix or something, for example, even though, really the first steps are more about building an MVP or a prototype and sort of validating, product market fit and that the assumptions are right and all that sort of thing. I'd say the same thing's true with AI. I mean, it is quite, an undertaking. It can be. So it's really understanding if it's actually needed or not, for example. And then also if you are going to go down that route, kind of what data do you currently have? What data do you need? And then having kind of a good plan as to how to use data and machine learning and artificial intelligence successfully is the key.
And Alex, what are the risks that an organization has to consider?
Yeah, I mean, there's quite a few considerations here. I mean, one of the things is, I think companies really need to have someone in a leadership position that understands artificial intelligence, machine learning, and data science. One of the things that I see a lot is with software engineers, for example, having been a longtime software engineer myself, a lot of times, languages or technologies or frameworks, platforms, whatever come and go. And, one of the things with software engineering is you want to stay current with your skill sets. And so a lot of times software engineers will kind of try and pursue, learning some of the new technologies, and rightfully so, to kind of keep current there. But what I'm seeing now with that is a lot of software engineers doing the same thing with wanting to learn artificial intelligence, for example. And right now, deep learning and TensorFlow have a lot of hype behind them. So, I see a lot of software engineers sort of immediately trying to kind of grab TensorFlow and play with it, learn a bit about deep learning. But I think one of the things there is that there's so many other aspects to artificial intelligence and machine learning that are really critical to learn almost first, right? Like having that sort of fundamental statistics and probability background, also understanding all the different other kinds of algorithms and approaches and techniques that are out there that aren't deep learning, because in the end, deep learning is not a one size fits all kind of approach. And in fact, often probably isn't the best approach, sort of that idea of starting simply and getting more complex as needed, as opposed to the other way around. But then, the other thing is with any machine learning or artificial intelligence project, there's so many critical trade-offs, considerations, and constraints really that the practitioners sort of working in AI and everything should be aware of, but also, as I mentioned, that sort of leadership type role that's mitigating risks and keeping all this stuff in mind. Some of those considerations, trade-offs, and constraints are things like, the bias versus variance trade-off, which sometimes is referred to as underfitting versus overfitting, or model performance versus interpretability, or model complexity versus simplicity. You get things like the curse of dimensionality, global versus local minima. And then there's a lot of, and this is becoming a lot more important these days with artificial intelligence specifically, are the different statistical, algorithmic, and cognitive biases that can surface in models that are created. So you can have things like sample or selection bias, but also, confirmation bias, and then algorithmic bias, where, models can learn to be a little biased towards genders or minorities or things like that. And that's really important to be aware of and avoid.
Well, Alex Castrounis, thank you for talking with us and answering 5 questions on artificial intelligence.
Thank you for having me. I appreciate it.